Alright, I got some blocks of wood set up on this side here. I slid this out a little further and I got to a point where all of a sudden now I can lift this back up off of here, which I wasn't able to do before. So, question is, can I lift this whole thing up off of here, or is it going to be too heavy? So I'm going to move these blocks out a little further. There's a part that sticks down underneath here that's kind of in the way. It's causing me some problems. Oh yeah, I can handle it. I had my Wheaties this morning. Alright, so now I should be able to sneak a peek underneath here and see if there's any reason why I shouldn't be able to just take my two screws back out and separate the apron from the saddle altogether. Put this down lower. Yeah, I don't see anything. I don't see anything to spoil. That's going to spoil my fun of doing that, other than the fact that it's just going to be really hard to manage. So, by the way, I can now clearly see that the two wall, it's a double wall apron here, and this back wall is screwed to the front wall from the back, so there was no way I was going to get that to separate without taking the apron off first. How do I want to do this? I want to do this in a way so that the apron doesn't fall over when I unscrew it. So let's see if I put this like this. A little space in there for this part that's sticking down in the middle. That'll sit like that. Put this up like this. Get my gigantic screwdriver. Reposition the camera. I pull this up off of here. The apron's going to want to fall back this way. So I should have a block of wood back there to protect it. That. Oh, a second pair of hands would be handy. Oh, there we go. All right. Oh, isn't that nice? It's nice that that wants to stand up on its own. Okay. Ah, very interesting. This little gear just fell out. And I'll tell you what this gear is. This gear is the gear that was on the crossfeed screw shaft right here. So it was up underneath here and it just fell out. And what this gear does is this gear meshes with the top of one of these driven worm drive deals here, or no, I'm sorry, meshes with this gear right here. Yeah, that's the ticket. Meshes with this gear right here, and that's the cross feed. It's got cross feed. Anyways, turns out this big screw I took out right here, that's the pivot point or axle for this gear. And take this gear out, the side with the stamped number on it faces in, so just in case it matters which way that goes in. Might not, but just in case it does. Alright, that gear, set with that one. So, my recommendation to anybody taking one of these off is leave your cross feed screw in so that this gear is held captive until you're ready to take it out. That might have been what was causing my hanging up problem when I tried dropping this off initially. You can imagine that gear was in there and causing trouble. So after I clean it up, I'll make sure I didn't damage it, but I don't see any signs of damage. Alright, so now this whole carriage could be cleaned. You know what? This is so filthy. I think I might put this right in the parts washer directly. Okay, before I put this in the parts washer, I'm just gonna sweep out this these heavy chunks of swarf. What do you call it? Swarf? Pronouncing it right. But basically, it's the pile of chips and heavy grease that's oil that's in here. That's that much less stuff I have to deal with settling to the bottom of my parts washer and needing to be cleaned out at some future date. Alright. Lift with the legs, not the back. That's good old American steel there. All right, I just finished my initial cleaning of the saddle, and you know, I'm gonna have to clean it a lot better than that to get all the grime and remnants of paint off before I paint it. But I wanted to show you underneath all that dirt and grime, what you couldn't see before, what I suspected was there. These little cover plates right here, shaped like an arrowhead, and what those are what are called the way wipers, or actually they're the retainers for the way wipers. So there's a couple little screws that were buried under all that grime. Take the screws out and you can take this off, and behind that, sandwiched between this little plate and the edge here of the saddle, is a piece of felt, and there's one of those on each end. And what they do, they have a very important job. What they do is they help distribute the oil on the ways, but they also are designed to hopefully block chips from getting underneath here and getting trapped between this surface and the surface of the ways and ground around. Okay, gather around, children. It's story time with Uncle Steve. He's going to tell you all he knows about the operation of the apron on this Hendey Lathe, which I didn't know anything about it a little while ago, and now that I can see the back of it, I was able to figure some things out. So basically, you've got the lead screw goes through here, passes through here, and engages this worm gear also, and then comes out the other end, goes underneath. This is the top half of the half nut, the bottom half is off right now, and then continues on its merry way. Well, basically what's happening is, as long as that lead screw is rotating, this is always rotating, and this is always rotating. And then what happens is, if you're threading, what you do is you engage the half nut lever, and of course this is the half nut. So the half nut control lever goes here. And then this bottom half of the half nut and this top half will sandwich that lead screw, and of course the carriage starts moving and it goes on its merry way. When you're not threading, this is disengaged, and what ends up happening is, if you want the carriage to feed automatically, there's a lever on the front. It's a knob actually that you tighten. And when you tighten the knob, it's actually on the back of this shaft right here. Your carriage feed friction clutch knob right here. When you tighten that knob, what happens is it actually engages a clutch and will cause the this gear, which is always rotating because it's meshing constantly with this, it'll cause it to lock up on that shaft and cause a gear down behind here to turn this big gear, which will turn this tooth, which meshes with the rack underneath the on the bed of the lathe and drives it along. So when you loosen that friction knob, what happens is this no longer drives this shaft. But you can also use the hand wheel, carriage feed hand wheel right here. And the hand wheel will drive this. So if you want to manually move the carriage, the hand wheel will drive this big gear, which again drives this and moves it along the rack. Now on this side over here, this one is always driving this worm gear below it right here, which is on this shaft. And on the other side of this is the friction knob for the cross feed. This is your cross feed friction clutch knob, goes here. So when you tighten that friction knob, what happens is this gear will start driving this shaft. It'll drive this gear behind here. This gear will mesh with the large gear that I took out of here, which pivoted on this screw that I took out. Okay, that large gear will mesh with this little gear, which sits up inside here and is actually on the cross feed shaft. So the lead screw for the cross feed is driven by this little gear, driven by the big gear, driven by the gear behind there. Again, only when that friction clutch is engaged. So you can actually have the carriage feed and the cross feed engaged at the same time. And I think I read in the manual that's actually one way to turn a very steep taper. If you have something that's got a really steep taper on it, you can do it that way. Another interesting feature is you see this rod down here with a spring on it. This actually goes over to here, and I believe that the way this works is this actually touches somewhere on that bottom assembly, a half nut that's removed. And I think the way this works is if you have the carriage drive engaged and you try and throw the half nut lever in, it'll activate this rod and disengage the drive. If you have a lathe that doesn't have that feature, obviously the danger is that if you throw the half nut in, it's going to be turning at a different rate than what this drive's going to be turning it at, and something's going to want to give, so that's not good. So I think I've got this pretty much figured out as to how this works. The one mystery I'm still having is on the other end of this shaft right here. And this is the control right here that I'm not quite sure of. So that lever has something to do with the drive here, and I'm not sure what. Also, you can see these teeth right here look really good, but then this almost looks like teeth behind it that are ground down. But that actually doesn't make much sense to me because that doesn't mesh with anything, because the lead screw's way back here, and this is wide enough to mesh with the rack, the toothed rack that's underneath the way. So what is this deal here? I think I'm going to put that lever on and rotate it and see what it does. Okay, so this is that lever that was on the other side. It's got a positive lock, so it can only be in one of two positions. So you're going to pull this spring-loaded knob to disengage it. And that goes on this shaft. This is the one, again, this is the one item that I do not know what this purpose of this is. So this does not have a friction knob on it like the other ones. Okay. Not sure what this is doing. It's actually turning the whole deal here. Yeah, I don't get it. Let's see. Alright, so now it's in the vertical position. And when I turn this knob, well, it's doing what I expected it to do. It's turning that rack to gear. So if I flip this down, what changes is the question. Lock this in. Okay, now that's in the down position. Oh, I can't turn that anymore. Gives. Oh, maybe this lever disengages the drive altogether? Something changed. I can't figure out what. Alright. So with the hand wheel on and that knob in the vertical position, or that lever in the vertical position, I obviously just manually operating the carriage at this point. This, even if it were being driven by the lead screw, would have no effect because I've got the friction clutch turned on. Now if I turn the friction clutch on, basically tighten this all the way in, what happens? Oh, I turned this, you know what I did? You gotta have the knob on it. What happens is when I turn this all the way and this unscrews, if I had the knob on there, it wouldn't be able to unscrew. It would actually tighten the clutch. I gotta have the knob on there to make that work. But I'm confident that that's the clutch. Oh, wait a minute. Here we go. Yeah, that's disengaged. That's engaged. Oh, but nothing's happening. I wonder if that's what this lever does. So now flip this lever down. Come on now. Be good. What if I could have this clutch disengaged to actuate this lever? Right. I think the clutch is disengaged there. Come on, be good. Ooh, that's turning the handle right there. Alright, now I get that locked in. Now I've got the lever locked in that second position. Now, still nothing happening here, no change. No, sir. I don't get it. Well, all else fails, could actually consult the operator's handbook for Hendey Lathes. Let's see. Of course, I could find a close-up of the apron, maybe. Let's see. Well, I know in the beginning there's a picture of the lathe with all of the call-outs. All right. Yeah, of course, it's not showing me that control on this one. And that's the problem with this being a 4th edition. This is for, I think, a later series. Oh, here we go. This is closer. Oh, let me get this in the camera for you. So, shed some light on the subject. So what we've got is, there's the friction knob for the cross feed clutch. There's the friction knob on the hand wheel for the carriage feed. So this arrow is pointing to my mystery lever. It is number 32. And 32 is the rack pinion eccentric lever. Oh, okay, that's it. It's the rack pinion eccentric lever. Why the heck didn't I think of that? Okay, so I don't know what that does. Okay, by definition, I know this much. Rack pinion eccentric lever. I know this is the rack pinion gear right here. Pretty sure. Because it's a little gear that measures with the rack. Eccentric lever. I know when you're talking about eccentricity, when it comes to a shaft, you're talking about whether or not that outside diameter of the shaft, whether the axis is perfectly centered, the axis of rotation, is it perfectly centered in the shaft or is it offset? So, see if I can explain that better. Well, here, let me do this. Alright, so let's pretend that this hose clamp, this circle, is the outside diameter of the gear. Okay? And let's pretend this screwdriver represents the axle that it rotates on. Okay? If I'm holding this right, pretend I'm holding this right in the dead center of this circle. Okay? That would mean that this gear would be rotating, it's eccentric. Or is it concentric? I forget, but basically what this lever is doing is there's a special, almost like a cam shaped shaft in there. So what happens is when you rotate that lever, what it'll have the effect of doing is it'll have the effect of shifting the position of this gear up or down or from side to side, depending on what the purpose of it is. So I'm thinking what this does, what this lever does, is I think it will lower this gear to where it no longer meshes with the rack at all. So I think with the lever in one position, this won't drive at all. And with it in the other position, it will. So let's say, for instance, that I had this in a position and I had the carriage locked down. I was doing a facing operation. If I have this lever in this position, right now this would not be meshing with the teeth on the rack at all. So if I'm correct on that, I believe if I rotate this lever up, what should happen that I didn't notice happening because I wasn't looking for it is this gear should actually move up or down. I'll tell you, this thing's hard to move. It's a lot easier to move it if I move the carriage hand wheel at the same time. There you go. See it? I don't know if you guys saw that on video or not, but you'll now look, you see now this tooth right here is sticking up above this right here. So that now would be fully engaged with the rack. So that would actually have an effect. And now we'll do it again the other way. You'll see it go down. There we go. Now, notice the top of this tooth barely is proud of this area right here. That's now completely disengaged. Mystery is solved. Well, a bunch of you already knew what that did, but mystery for me is solved anyways. I like knowing how things work. Certainly. So all of these little nubs you see right here can be unscrewed, and oil is injected into those holes and follows along little capillary tubes and drips into critical areas.